One way to look at the cast system is whatever you have. You can almost see it like drawing a circle. Okay, so you have your CAST, and the idea is this is your 0 and 360.
Yeah.
And you're going around in a circle. So, thanks. Think of a circle with a radius of 1. So the whole idea behind it is that you're trying to figure out what the distance of r is constantly. So for instance, if you were to go sine 90, so if you were to move 90 degrees, so that's going from here up to here, the distance from here to here is 1 because this circle's radius is 1. Okay?
Yeah.
Same thing if you're at 180. This is the reason that sine 180 is 0 is because you're here. You're flat on line in terms of height. Think of this like a y-axis. So we have 0, the tip is 1, and the other, peak and trough is -1. So this wave is essentially just kind of like if you were to go around the circle. So if you were to type in sine 270 into a calculator, you'd end up with -1. Oops. And then if you got to 360 again, you'd be back at 0. So when moving from sine, it's like starting from here. And if you have a cosine, it's a wave that looks like this. And all this is doing is kind of showing what it would be like if you'd start with cosine. So sine, think of as you start at this point of the circle and you're moving around the circle. Cosine, at 0 you start at 1. So actually I should do cosine. Well, cosine you start from here and be like moving around the circle. So if you were to go 90 degrees from here, you're actually at 0, is the whole idea.
Okay.
If you go 180 from here, you're at -1. If you go 270 from here, you're at 0. If you go 360, you're back at 1. So cosine would start there. So think of it as like anything to do with sine, you start at this point. And anything to do cosine, you could say that you start here. In terms of trying to figure out what the degrees are equal. Now, you guys, I'm pretty sure, will be dealing with radians. Have you guys done that? 2 pi.
No.
Oh, you guys haven't done that? Oh, okay. If you haven't done radians, then maybe you guys are just. Idea, I guess, behind what you guys are doing is you're trying to find theta with a lot of this stuff. So if you have, the whole idea is to set up a right angle triangle. Let's do this in permanent. So you're setting up a right angle triangle, looking for theta. R, excuse me, R stands for radius. So think of it as like a circle. This is the y. Like I said, the highest you can get is 1. And this is movement on the x. So think of this line across here as an x-axis, and this line up here as a y-axis. So the highest peak you can get is at 1, and the lowest is -1, and anything in between is our distance of r. So r is technically 1 all the way around this circle, because the radius will be the same no matter where you are. It's your y and your x that are going to change, depending on their distances. There are 2. Okay, so there's 2 special triangles you have to remember, and pretty much they deal with 45 degrees. They're always right angle triangles, right? So if this is 45, that means the other one has to be 45. So this is like an isosceles triangle. These 2 distances are the same. And one way to think of it is if this is 1 and this is 1, according to Pythagorean's theorem, where you have a squared plus b squared equals c squared, right?
Mm-hmm.
Well, we're kind of dealing with, think of it now that everything we do is this is an x across here, this is a y, so our a and b are represented by x and y, and our c, we're just going to call r for radius. So we're going to try to relate them to the circle instead of using what they've given us. So in other words, think of it like x squared plus y squared equals r squared. Yeah. So this is our r, x and y. So since A and B, they don't, well, actually no, they can't matter in this case because think of this as this will be our x because it's horizontal, and this will be our y. So x is 1 and y is 1, so 1 squared plus 1 squared is, do you know? I'll draw it up for you what I'm saying. So if this was our x was 1, and y was 1. I replaced y with 1, x with 1. So I have 1 squared plus 1 squared.
It's 2.
Yeah, it's just going to be 2, right? Equals 2r squared. To figure out what r is, I have to square root it, so it's the root of 2, instead of finding out what the actual number is.
Yeah.
So that's the one case of the special triangle.
Okay.
So that's one of the ones you have. You have to have that one memorized. Anytime you have 245 degrees, have you guys done like ratios? Technically, I could draw an even bigger triangle. So it could be 2, 2, and then it's kind of like a scale triangle, but these are the ones they want you to deal with. The other one they want you to deal with is 30 degrees, 60 degrees, and obviously that's 90. In this one, you have the distances of, now I believe in your book, let me make sure I didn't write this. Sometimes I write the 1630 back. Okay, so this distance is 1, this distance is the root of 3, and this distance is 2. Okay? So you can always draw triangles to scale like this, and you can, once again, you can think of this as our x, our y, and then this ends up being our r. Okay, the distance here. So if we have 60 and 30 and 90. Okay, so whatever we're drawing, we're trying to figure out distances based off of a circle like this using these degrees. So we would redraw all of these degrees in there, and we can change the type of circle we have. So let's see if we can get a question here. Okay, so let's say they give you sine 45. What they're looking for. Okay, so 45. What that means is that we're dealing with one of the special triangles. Remember, there's always 2 of them. So if they're asking for sine 45, technically in this case it doesn't matter which one, which angle I'm talking about. But since we're used to the cast system, let's actually get a circle out here. I'll pause this so we don't waste time. Okay, so here's our idea. We have our circle. This is our x, this is our y. Cosine, all things are positive. You know what the cast stands for? Okay. So if they're asking for sine of 45, we have our 45 degrees, right? We're looking for sine of 45. Well, we know that the distance here to here is 1, right? That's what we've been dealing with. Our distance here to here is going to be 1. So then this circle is going to be dealing with a radius of r squared, right? Or sorry, square root of 2. So if they ask us for sine, if you remember the rules for sine, sine is opposite over hypotenuse. So the whole idea that sine 45 is equal to opposite over hypotenuse. Well, in this case, the opposite is 1. The hypotenuse is the root of 2. So we know that sine 45 is equal to 1 divided by root 2. So we can always use this ratio to solve for one or the other. So for instance, if they're asking us for the distance of a side and they've given us sine 45, we can tell them the opposite is this. We can tell them what the ratio is. If they've given us 1 divided by the root of 2, we can always tell them that theta is 45. So this is, think of this as an equality.
My teacher hates when the root is underneath, so she makes us multiply by 2. So that's why here it's like sine of 45 is root 2 over 2.
Oh, she wants
So
the root to be on the top?
Yeah.
Okay.
It's just her.
So if you were to multiply, does she multiply? She multiplies by root 2.
Yeah.
Yeah. So in other words, what this says is sine 45.
Root 2.
Yeah. So you just, the idea is that you're multiplying both the top and the bottom by root 2, because if you multiply the bottom by root 2, your answer is going to be 2.
Yeah.
Yeah. Okay. So that makes sense, right? So you get root 2 over 2. So it's the same idea. All it is a ratio.
Yeah.
So you're making the triangle bigger, kind of thing. So in that case, this triangle would kind of look like this. This will be 2, and this is root 2, which means this is also root 2. These are 45. So this is just a larger triangle. That's all they've done. Yeah, you can scale triangles to go larger and bigger any way you want. Okay, so the information they've given you here is they've actually told you two sides of the triangle. You can solve for them. Okay, it's a ratio. So this is set up as a ratio. So they've told you that this length is 14, but if we were to use our special triangles, we could technically draw a smaller triangle. Well, whatever. Where this distance isn't 14, because we know sine is opposite over hypotenuse. So what this is telling us, say that this triangle here is just a smaller scale of the bigger one. We know that our opposite side is 1, and we know that our hypotenuse is 2. Okay, so they've told you that is sine 1 over 2 is our opposite our hypotenuse. Now in the actual triangle they've shown us, they've told us this distance is 14. Well, we know from scale that the hypotenuse is going to be twice as long as this side here. So if this side is 14, that means we're looking this to be 28, yeah. We're looking at a distance of 28 here. So they want us to kind of go through it that way. Once you have this, you have now enough information using Pythagoreans to solve this side. You can also use sine and cosine law to solve for this side and this side here. Do you remember doing those at all? No? Sine law and cosine law? So, okay, let's think of Pythagoreans first of all to deal with this side. We have a squared plus b squared equals c squared. C squared is actually 28, and this is 14 squared equals, oops, not equals, plus b squared. We're trying to solve b. We're going to call this side b. Okay? Let's go so we have more room. So we have 14 squared plus b squared equals 28 squared. Do you have a calculator? Yeah. It's 28 squared.
5.29.
Squared? Ah, you found the square root.
Okay.
Yeah.
784.
74. And what's 14 squared?
196.
196. Okay. So you know how to solve for b here? I would essentially b squared, I move 196 to the other side. Subtract by 196. We get 588, and we got to find the root of that. 24.2. So essentially, our other distance here should be 24.2. So using Pythagorean, we found those three sides. And then here, depending on which side I want us to find, how much time do I gotta do it under 15 minutes. We'll call this A and this B. Depending on which one we want to solve for, we use different sine ratios. So, sorry, let's go back up. Let's say we're solving for B. I have an angle, and I have an opposite side of that angle. So if I'm trying to solve for B, tangent is the opposite side. I'm not going to draw an O because it circles. Opposite and adjacent. And this is our adjacent side here. And we have opposite measure. What's that? Oh, okay, I'll write it permanent. Just because when I see how this thing disappears, when I draw an O with that, it does that.
Oh.
Yeah, that's the only reason I didn't draw an O. So let's say we want to solve for B, we would use our tangent ratio. Tangent is opposite over adjacent.
What if you only had one of those? Like, okay, wait. So 14 is the...
So because this side was 14, and we know these two angles are 45, we know that this side has to be 14. Okay? And on top of it here, I'm going to redraw the special triangle down there in a second.